Hello students, welcome to the first lecture on the lecture series on time, speed and distance. Okay, so in this lecture what we'll be covering is we'll be covering some basic concepts and some types of problems that are usually being asked on various competitive exams. So this will be the first lecture on this lecture series. So let's start. So what is speed? What is time? What is distance? We all know time is a fundamental quantity. So time is a fundamental quantity, right? And what is distance? Okay, so it is the space between two-dimensional space. So distance is nothing but 2D space between 2 points. And what is speed? Speed is a term that represents speed is equal to distance by time. So distance by time represents speed. Okay, so distance and time are everywhere in our lives and shaping how we move, work, play and interact with world around us. Okay, so let's try to understand these things. Okay, so what is distance, what is time, what is distance, speed, time relation speed, what is average speed, what is relative speed. Okay, these are some key concepts that we need in this topic. And some other key concepts are time and work, conversion of units, uniform speed, relative speed. Okay, so what is time and work, what is conversion of units? Okay, what are units? Okay, so what is uniform speed, what is non-uniform speed, what is relative speed? Okay, and how it is different from normal speed. Okay, so let's go forward and start with the first topic, that is distance. Okay, so distance is the length of space between 2 points. Okay, so the length of space in 2 dimension. Okay, it is always in 2 dimension. Okay, so between 2 points it doesn't have a direction, so it is referred to as a scalar quantity. So distance is a scalar quantity. So scalar quantity. Okay, so there are other scalar quantities also. So distance is another scalar quantity. So units for distance include what? Meters, in metric system. Okay, we also use what? Centimeter. Okay, and inch, kilometer. Okay, mile. Okay, these are the terms that we also use for length. Okay, but in metric system the standard is meters. Okay, so let's go forward with the second type of concept, that is time. So sequence of events that occur in succession. Okay, so unit for time are seconds, minutes and hours, etc. Okay, we also denote time in astronomical year and in what? Days, weeks, okay, years. Okay, so let's go forward with the third kind of concept, that is distance, speed and time relationship. Okay, so what is the relationship between these three? Okay, between all these. So let's go forward and see. So it is actually represented by this formula, that is speed is equal to distance by time. Okay, so in order to calculate speed, what you need is you need distance if it is in meters, and in time in seconds. Okay, so when you combine distance and time, you arrive at a concept of speed. Okay, so speed is a concept that is developed using the relationship between these two. Okay, that is distance and time. Okay, which actually describes how fast something is moving or happening. Okay, so speed is defined as the distance covered per unit time. Okay, so if t is equal to 1, okay, then it is in unit time, so it will be what? Speed is equal to distance per unit time. Okay, so speed is defined as the distance covered per unit time. So let's see the concept of average speed. So what is average speed? Okay, and how it is different from normal speed? Okay, suppose you were going from place city A to city B. Okay, city A to city B you were going. Okay, but there was, for half the distance, okay, up to half distance, what you had was you had a 45-degree slope angle, 45-degree slope. Okay, that is upwards. So with this 45-degree slope, what your bike can do is it can go, but it can go at a slower speed, right? And after it has a 45-degree downward slope. Okay, 45-degree slope but downward. Okay, so what will happen is your bike will go faster because it is on a downward slope. Okay, so what happens is when you are traveling from city A to city B, you were going at two different speeds, right? When you were going from city A to half the distance up to city B, your speed was lowered because there was a 45-degree upward slope. And after that half distance, Okay, what happened was the speed got marginally better. Okay, because there was a 45-degree downward slope. Okay, so you had two different speeds. Okay, but how can we say? Because we know that speed is equal to what? Speed is equal to distance by time. But here you can see that at no point you can calculate the speed using this formula. Okay, so this speed is here average speed if we try to denote using the whole distance. So average speed is the total distance covered divided by total time taken. Okay, so in order to calculate the average speed between city A and city B, what you will do is you will use average speed. Okay, but let's say the middle point is C. But in order to calculate the speed between what? City A and city C, it is easy because the speed will be fixed. Okay, whenever the speed varies, we rely on average speed. Okay, so the formula for average speed is equal to total distance by total time. So let's see a special case. So if two objects with speed s1 and s2 cover the distance d. Okay, let's say there are two objects that is with speed s1 and s2 cover the same distance in d. Then their average speed will be 2 into s1 into s2 whole by s1 plus s2. Okay, if they cover the same distance with two different speeds, that is s1 and s2. Okay, so let's see the concept of relative speed. So we have learned speed, average speed. Now what we will learn is we will learn relative speed. Okay, so what is relative speed? So relative speed is nothing but when two objects are moving in the same direction and in opposite directions. Okay, so we calculate their relative velocity or relative speeds. Okay, and how it is relevant we'll see in this lecture. So in problems involving two objects moving towards or away from each other. Okay, either they are moving in the same direction or they are, so we'll learn what is relative speed, or they are moving in opposite direction, right? Either this case or this case. Okay, only one can happen. So relative speed is used to find the effective speed between them. Okay, so let's say you have a problem where A is moving towards B. Okay, so A is moving towards B. Okay, so we can actually convert this scenario to B is fixed and A is moving at some speed towards B, right? And if they are moving in same direction for this case, okay, so if they are moving in same direction, we can also make it happen that if B is here, then A is where? Okay, so B is fixed but A is moving at a special speed, that is called the relative speed. Okay, in that way we can fix one point or one object and say the other is actually moving away or towards it at some certain speed. Okay, that speed is called relative speed. Okay, so this concept will actually help us to deal with dynamical problems. Okay, where multiple bodies are moving towards or with each other. Okay, we can convert it to some kind of problem where everything is fixed but only one is moving. Okay, in that way we can make the problem very easier. Okay, so in simple terms, it's like figuring out the difference speed between two moving things. So to see who is moving faster if they are going in the same speed. So the formula for relative speed is, so there are two scenarios as we have discussed. Either they are moving towards each other or they are moving with each other. Okay, so relative speed is equal to speed of object 1 into plus speed of object 2 when they are moving in the same direction. In the opposite direction, it will be in the opposite direction. Okay, so relative speed is equal to what? Speed of object 1 minus speed of object 2 when they are moving in same direction, right? So when they are moving in same direction and when they are moving in opposite direction. Okay, where object 1 is greater than object 1 speed is greater than object 2 speed. Okay, so let's see problem number 6 or concept number 6. So it is based on time and actually work. Okay, how time and work is actually involved in this topic, that is speed, time and distance. So the concept used in time and work problems where work done by individual or group is related to time taken to complete the work. So work, time and work directly relates to what? Time. Okay, the speed of work or work rate. We have already discussed this in the time and work topic. Okay, so work rate directly relates to speed and time. Okay, so let's see the seventh kind of concept, that is conversion of units. So candidates often need to convert units of distance, that is meter to kilometers, and unit of time, so that is seconds to hours. So to ensure consistent calculations. Okay. So let's see the 8th kind of concept, that is on uniform speed. So in problems where an object travels at a constant speed, the concept of uniform speed is used to simplify calculation. Okay. So let's see the 9th kind of concept, that is relative motion. So this concept is actually used to find the effective speed and time taken when two objects are moving in the same or opposite direction. Okay. So it is nothing but the relative speed concept. So this is relative speed concept. Okay. So we have already learned this. Okay. So let's go forward with the types of questions. So we have covered these 9 type of concepts that will be used in this topic, that is distance, time, distance, speed and time relationship, what is average speed and how it is different from speed, and what is relative speed and how relative speed is different from average speed. Okay. So how these three are different we have learned. Okay. So we have learned also what is time and work and how it is related to speed, time and distance. We have also learned conversion of units, uniform speed and relative speed. Okay. So let's go forward with the types of question. Okay. So the first kind of question will be based on simple speed, distance and time problems. And the second one will be on average speed problems. And the third one will be relative speed problems. And the fourth will be the train problems. Fifth will be the boat and stream problems. Okay. So the sixth one will be on escalator and staircase problem. Okay. So these are very interesting scenarios where we can see how speed, distance and time, okay, juggle with each other and give us different scenarios with different kind of surprises. Okay. So we'll see the 7th kind of question, that is on time and work problem. And the 8th one will be on circular track problems. And the 9th one will be on relative motion problems. And the 10th one will be on time and distance in races. Okay. In races, how time and distance play a crucial role. So let's see the type of one question, that is simple speed, distance and time problem. So to find out the speed, distance or time of a given problem. Okay. So let's see the first problem, that is a car travels at a speed of 60 km per hour. So this is the speed. Okay. So speed is 60 km per hour. So how long will it take to cover a distance of 240 meters? Okay. Here you can see that speed is in kilometer per hour, right? And we want to convert it to meter per second, right? This is what we want to do. So kilometer per hour is equal to what? 1000 meters per 3600 seconds, right? So cancelling the zeros out, what we are left with is 10 by 36. So it will be what? It will be 5 by 18. So by multiplying 60 with 5 by 18, what we do is from 60 km per hour, it is converted now to meter per second. So this will be equal to what? So it will be 6 and this will be 20. So it will be 10 and this will be 3. So it will be what? 50 by 3. This much meter per second. Okay. So to cover a distance of 240 meters, okay, we know the speed distance formula, that is speed is equal to distance by time, right? So distance by time. So this is equal to distance will be what? 240. So 240 by time we don't know. So let's take time into the left hand side and speed to the right hand denominator. So it will be speed will be what? 50 by 3, right? So this is equal to 240 into 3 by 50. So cancelling a 0 out, what we are left with is 3 into 24. It will be 72 by 5. Okay, so 72 by 5 seconds. Okay. So given that the speed of car is this much. Okay. So distance will be, the distance is also what we can do is, as we converted kilometer to meter per second, right? We can also convert this meters up to kilometers and then get the solution. So distance will be 240 meter is equal to what? 0.24 kilometer. Okay. So time is equal to distance by speed. So time is equal to this, that is distance, that is 240 meters or 0.24 kilometers. And in the speed we have 60 kilometer per hour. So we have to 60 here. So time will be 0.004 hours approximately. Okay. So this will be the approximate answer. And the accurate answer will be what? 50 by 3. Okay. So this will be actually equal to 16.67 seconds. Okay, so it will take the car for around 0. This much hour or 16.67 seconds to cover the distance of 240 kilometers. It is not kilometers, it will be only meters. Okay, so let's see the second kind of question, that is on average speed problem. So to find out the average speed of a given problem, okay, so a person travels 120 kilometer at a speed of 40 kilometer per hour and then 180 kilometer at a speed of 60 kilometer per hour. Then find the average speed. So average speed A will be equal to 2 into, okay, so it will be 120. No, it will be what? So it will find the average speed for the entire journey, right? So person travels 120 kilometer at a speed of this much and then 180 kilometer at a speed of this much. Okay, so for the first, let's calculate the time. So t1 is equal to first part of the travel. Okay, so it will be what? So t1 will be distance, that is 120 by 40 is equal to 3, so 3 hours. So t2 will be what? So it will be 180 by 60 is equal to that much amount, that is 3 hours. Okay, then for average speed, what we do is, this is equal to distance 1 plus distance 2, 120 plus 180 whole by 3 plus 3 is equal to 6. This is equal to what? So it will be 300 by 6 is equal to 50 kilometer per hour will be the average speed. Okay, so distance 1 is equal to 120 kilometers, so speed 1 is equal to 40. Okay, so distance 2 is equal to 180 and speed 2 is equal to 60. Okay, so to calculate the total time taken for each segment of the journey, time taken for segment 1 t1 is equal to a distance 1 by speed. So time taken for segment 1, that is t1, is equal to 120 by 4 is equal to 3 hours. Okay, so for the segment 2, that is t2, the time taken will be t2. So t2 is what? Distance 2 by speed. Okay, so time taken for segment 2 will be what? 180 by 60, that is equal to 3 hours. Okay, so calculate the total distance and total time for the entire journey. So total distance will be what? Distance 1 plus distance 2 and total distance will become 300 kilometer. Okay, so total time will be what? Time taken for segment 1 plus time taken for segment 2. So 3 hour plus 3 hour is equal to what? 6 hour, right? So 6 hour will be the total time. So use the formula, average speed is equal to total distance by total time. So 300 kilometer by 6 hours will be what? 50 kilometer per hour. So the average speed of the entire journey will be 50 kilometer per hour. Okay, so let's see the third kind of question, that is on relative speed problem. So relative speed problem involve calculating the speed of motion of one object relative to another. Okay, in this scenario, what we do is we use the formulas and then convert the scenario to a simpler scenario. Okay, where multiple objects are not moving, only one object is moving, but multiple objects are still. Okay, so these problems often arise when 2 or more objects are moving in different direction or at the same direction. Okay, so we need to determine their relative motion or positions. So let's see the problem. So 2 trains are moving towards each other. Okay, in this case it is moving towards each other. Okay, so it is A and it is B. So A train is moving towards B and B train is moving towards A. So if train A travels at 80 km per hour and train B travels at 60 km per hour, then the distance between them is what? 300 km per hour, right? So how long will it take for them to meet? Okay, so in this case both of them are moving. So what we want to do is we want to convert it into a scenario where only A is moving and B is still. Okay, so since they are moving in opposite direction, what will be the relative speed? So relative speed is equal to speed of A plus speed of B, that will be what? 80 plus 60, that is equal to 140 km per hour, right? So this is the speed of relative speed. Okay, so now what we can assume is, since in this case what A was doing is A was going at 80 km per hour and B was going at 60 km per hour, right? But what we can assume right now is A is going at 140 km per hour and B is still there. Okay, B is still there with 0 km per hour speed. Okay, so how much? So the distance between them is 300 km. So given that the distance is 300 km. Okay, now we want to calculate the time taken. Okay, So time is equal to what? Time is equal to distance by speed. So this is equal to 300 by 140. So cancelling a 0 out, what we are left with is 30 by 14 is equal to 15 by 7. So this much amount of what? Time or R. Okay. So let's see the step-by-step solution. So given speed of train A, that is S1 is equal to 80 km per hour, and speed of train B S2 is equal to 60 km per hour, and distance D is equal to 300 km per hour, right? So relative speed is equal to what? Speed of train A plus speed of train B. So 80 km per hour plus 60 km per hour is equal to 140 km per hour. So time will be 300 by 140. So cancelling a 0 out, what we are left with is 15 by 7 hour. Okay. So time will be 2.14 hours approximately. So it will take approximately 2.14 hours for the two trains to meet. So train problem. So train problem involves calculating either the distance traveled by a train or the time it takes to travel a certain distance, typically given its speed. So train A crosses a pole in 15 seconds, and another train B, which is 250 meters long, crosses the same pole in 10 seconds. So having the same speed, then find the length of train A. So given that length of train B is equal to what? 250 km, time taken by train B to cross the pole is 10 seconds. So the speed of train is equal to what? So here is a pole and here is the train. Okay. As it passes through. Okay. So as it reaches here, the time starts. And as it ends here, the time stops. So 250 meter in 10 seconds. So speed of train is equal to speed of B. Okay. So A crosses the pole in 50 seconds. Okay. Which is 250 kilometers. Sorry. And another train B crosses in 10 seconds. So it will be what? So 250 by 10 is equal to 25 meter per second. Okay. This is the speed of train B. Okay. So it tells us that train A crosses the pole in 15 seconds. Okay. So if it crosses it in 15 seconds, then find the length of train A. Okay. So calculate the speed of train B. Speed of train will be 25 meter per second. Okay. Since train A crosses the pole in 15 seconds, its speed is same as the speed of train B. Okay. So use the formula for length L. So speed into time is equal to what? Length of train A is equal to speed of train A into time taken by train A to cross the pole. Okay. So it is 25 meter per second into 15, that will be 375 meters. Okay. So the length of train A is 375 meters. So boat and stream problem. So it is used to determine the speed of boat in still water or the rate of stream's current when you have information about the boat speed in certain conditions. Okay. So a boat can travel at 18 km per hour in still water. So if it moves upstream in a river of current 3 km per hour, what is the speed of the boat against the current? Okay. So against the current, its speed will be the relative speed. So we know that only in relative speed, what we have is only two concepts, right? Two concepts. That is either they are moving towards each other or they are moving with each other or along each other. Okay. So it can travel at 18 km per hour in still water. So since in this case it is moving upstream, so their speed will be in opposite direction, right? So relative speed is equal to 18 plus 3 because the current is in opposite direction as the boat is moving upstream. So this will be equal to 21. So this much kilometer per hour will be there, the speed of the boat against the current. Okay. So given that speed of the boat in still water is this much and speed of current is equal to 3 km. So speed of the boat is equal to speed of the boat against the current will be speed of the boat in still water plus speed of the current. Okay. So it will be 15 plus 3 is equal to 18 plus 3 is equal to, this will be 21 km per hour. Okay. So the speed of the boat against the current will be. So let's see the problem. So a boat can travel 18 km per hour in still water. Okay. If it moves upstream in a river with current of 3 km per hour. Okay. In this case, the boat is moving in this direction. So this is the moving direction of the boat and this is the current of the river because it is moving upstream, right? In the opposite stream. So the relative speed will be what? So relative speed will be addition of these two, that is equal to 18 plus 3 is equal to 21 kilometer per hour. Okay, so what is the speed of the boat against the current? Okay, so against the current, the speed of the boat will be, so against the current, speed of boat is equal to what? It will be 18 minus 3. Okay, that is equal to 15 kilometer per hour. Okay, so given that speed of the boat in still water is this much and current is this much. Okay, so speed of the boat against the current will be speed of the boat in still water minus speed of the current. So 18 minus 3 is equal to what? 15 kilometer per hour. So the speed of the boat against the current will be this much amount. So the speed of the boat against the current is 15 kilometer per hour. So let's see the sixth kind of question, that is escalator and staircase problem. So in this problem, an individual is typically walking off or down a moving escalator, continuously moving staircase at their own speed. And the challenge is to determine various parameters such that the time taken to traverse a certain distance or effective speed of the person. So let's see a problem on it to better grasp at it. So an escalator takes 30 seconds to reach the top of a staircase, moving at a speed of 2 steps per second. How much time will a person take to reach at the top of the staircase which has 100 steps? Okay, so if they walk up the stairs at a speed of 4 steps per second, how much? So given that the speed of the escalator is what? 2 steps per second, and time taken by the escalator to reach the top is 30 seconds. So number of steps in the staircase is equal to 100. So speed of the person walking up the stairs will be 4 steps per second. Okay, this is what given. So calculate the total distance covered by the escalator. So total distance covered by the escalator will be equal to what? Speed of the escalator into time taken by the escalator, because speed is equal to distance by time, right? So this formula is used here. So distance covered by the escalator is equal to 2 steps per second into 30 is equal to 60 steps. So calculate the effective speed of the person walking up the stairs. So effective speed of the person is equal to speed of the person walking up the stairs plus speed of the escalator. So effective speed of the person will be what? 4 plus 2, okay, steps per second. So it will be 6 steps per second. So using the formula time is equal to distance by time. So number of steps in the staircase by effective speed of the person is equal to, okay, time taken for the person to reach up the top of the staircase. Okay, it will be 100 by 6. So it will be 16.66 seconds or 16.67 seconds. So the person will take 16.66 seconds to reach the top of the staircase. So let's see the seventh kind of problem, that is on time work problem. Okay, so a team of 5 workers can actually complete a task in 12 days. Okay, how long will it take for the same task to be completed in 10 workers are working together? Okay, number of workers is equal to 5, number of days is equal to 12, number of workers is equal to 10. So 5 into 12 is equal to 60 days. So 6 days 10 workers can actually complete. So 60 by 10 is equal to 6 days. So it will take 6 days for 10 workers to complete the same work. So let's see the 8th kind of problem, that is circular track problem. So calculating the distance and time it takes for an object to travel around a circular path. Okay, so 2 cyclists start from the same point on a circular track of 400 meters. So one completes a lap in 2 minutes, right? So while the other completes the lap in 3 minutes. So find after the what distance they'll meet again at the same starting point for the first time point. So LCM of 2 and 3 is equal to 6. So they'll meet again at the same starting point after 6 minutes. So cyclist 1 would have covered 3 laps and cyclist 2 would have covered 2 laps, that is 800 meters and 1200 meters for 2 and 1 respectively. So the 9th kind of question will be on relative motion problem. Okay, so that will be based on relative speed problem. So 2 friends A and B start from the same point and walk in opposite direction. A walks at 5 km per hour and B walks at 4 km per hour. So how far they will be apart after 1 hour? Okay, so their relative speed is equal to relative AB is equal to, so it will be 5 plus 4 is equal to 9. So they will be 9 km apart. Okay, because this is the distance covered per unit time. Your unit time is given, that is 1 hour. So that's why we have directly written 9 km apart. Okay, so let's see the step-by-step solution. So given speed of A is equal to S1, that is equal to 5 km per hour. Speed of B will be 4 km per hour. So time is 1 hour. So relative speed is equal to 5 plus 4 km per hour is equal to 9 km per hour. Okay, since the time is 1 hour, so distance apart after 1 hour is equal to 9 km per hour into 1 hour, that is equal to 9 km. So they will be 9 kilometers apart after 1 hour. Okay, so the 10th kind of problem is on time, distance and races problem. Okay, in a 100-meter race, A covers first 60 meters in 6 seconds and the remaining distance in 4 seconds. What is the average speed? Okay, so total distance is equal to what? 100 meters, right? So total time taken. Okay, so T1 plus T2. We can divide it in these two. So this will be what? 100 by 4 plus 6 is equal to 10. Okay, so 100 by 10 is equal to 10. So total distance 100 and total time is equal to 6. So 60 by 6 is equal to 10 meter per second. Okay, so 10 meters per second will be the correct answer. So that's all for now. Thank you.